Hi, my name is Georgiou, and today I will introduce FacadeNet, a collaborative project involving the University of Cyprus, Science Center of Excellence, and KAUST University. The primary objective of FacadeNet is to create coherent multi-view facade images by leveraging a large-scale dataset that includes facade images and their corresponding camera views as input. Our objective is to employ a network for capturing and encoding the features related to the structure and style of a reference facade. Given the structural encoding and the incorporation of target camera view as conditional information, during the generative process, the decoder network is enabled to generate realistic facades that align with the specified parameters. By changing the camera position must result in corresponding adjustments in the generated images, while maintaining the structure and style of the reference facade. The encoder and decoder together form our proposed network, the FacadeNet. There is plenty of prior work around novel view synthesis. An example is deep stereo, where the attempt is made to interpolate points from different views to assemble a novel one. Other approaches, such as stereo magnification, utilize multiplane image representations to predict the movement of objects between views. The NERF approach has made a significant impact, with numerous papers building on this work. Neural reference field is optimized to represent a single 3D scene by leveraging a set of 2D images. Diffusion models present a valid and recent alternative to GANs. An example is Palette, a conditional diffusion model that yields high-quality results. Other diffusion-based approaches like ILVR successfully address conditional tasks by employing latent variable refinement, where the statistics of the novel image are guided towards a specific reference. However, it's worth noting that editing tasks pose a more intricate challenge for diffusion models. Generative adversarial networks have been widely employed for diverse image generation tasks and editing. One approach involves optimizing style latent codes on pretrained generators, such as StyleGAN2. Additionally, SPADE introduces an architecture that utilizes semantic segmentation masks to generate realistic landscape images, while swapping autoencoder presents an approach aiming to enforce disentanglement between style and structure. The authors demonstrate that latent structure tensors and style vectors can be arbitrarily swapped to generate novel combinations. Currently, 3D-aware synthesis techniques demonstrate sampling capabilities comparable to tuned GANs. A notable example is illustrated in the efficient geometry-aware 3D GANs paper. However, their efficiency relies on well-curated datasets with aligned structures and scales. On the other hand, recent studies of 3D generation on ImageNet have addressed the previous challenges. This approach involves training models to learn post-distribution from single-view data, departing from the reliance of multi-view observations. In a similar vein, our approach eliminates the need for known camera poses. One of our primary motivations stems from the growing demand for rich visual representations of building facades across various sectors that require convenient 3D visualizations. Another motivation is the opportunity to enhance existing urban facade datasets by improving problematic facades that exhibit high distortions. Intuitively, this challenge can be addressed by synthesizing the rectified facade from a more optimal viewpoint. The primary challenge for our task is that we need to enable multi-view synthesis, while our data do not contain multiple views from the same facade. Another challenge involves the disentanglement between the structure of the facade and the view direction of the camera. So initially, our pipeline processes a reference image and employs an encoder to create a latent tensor representation capturing the structure and style of the reference facade. Subsequently, given horizontal and vertical target angles theta, our generator leverages the inherent structure from the Z tensor and the view direction from conditional information to generate facade images. During training, our network tries to first reconstruct the reference facade by utilizing reconstruction laws to penalize the similarities between reference and reconstructed facade images. Furthermore, a discriminator is utilized to enforce realistic image generation while also being conditioned on the camera view. The decision of our discriminator takes into consideration the target camera view. In terms of novel view-generated images, the selective editing module is employed to determine the view-dependent parts of the reference image. The edit mask M highlights the areas that must remain consistent between different views. Consequently, the selective editing loss aims to minimize the dissimilarity between the reference and novel-generated images concerning the view-independent areas. The selective editing module is designed to generate masks that facilitate changes only to the features necessary for novel view generation. This minimizes the changes made by our generator, leading to superior consistency between views. More precisely, the selective module takes the reference image as input. Then we pass the facade image through a pre-trained self-supervised vision transformer and extract key representations from the last attention layer. To retain high-frequency information from the underlying data distribution, we apply principal component analysis to this embedding. By selecting the top 4 principal components, we capture the main features. For the creation of the selective editing mask, we employ a learnable blending layer. This layer learns how to combine the principal components to highlight editable areas within the reference image. Regarding our results, we compare our approach with a variety of prior works that combine diffusion, GAN, and 3D GAN-based approaches. Through FID scores, we demonstrate that FacadeNet achieves greater synthesis quality than other methods, while LPIPS scores indicates that FacadeNet outperforms other methods in terms of interframe consistency between different camera views. Here we display view interpolation for 3 distinct reference facade images. Our observations indicate that view interpolation selectively alters only the view-dependent areas. Further, we provide a visual comparison with other methods, and upon observation, it is noted that 3DGP and palette can generate novel views. However, the results are considerably more blurry compared to FacadeNet. The comparison between swapping-node encoder and FacadeNet reveals the swapping-node encoder generate artifacts, particularly noticeable in extreme viewpoints. Lastly, FacadeNet enables the development of novel applications, such as an improved rectified image application. This application involves synthesizing a problematic facade image from better views, resulting in higher quality information for problematic areas. Another application involves the development of view-independent adaptive facade textures that can conveniently assemble a realistic 3D urban scene. To summarize, we present a novel conditional GAN that synthesizes built-in facade images from different viewpoints, given only a single input image. We introduce a selective editing module that enables effective focus on view-dependent facade features. And additionally, we introduce 2 novel urban environment applications. Please visit our project page for more details. Thank you.